Hey everyone, we are solving lead code question first missing positive. This question is classified as hard and we are given an integer array nums which is unsorted. We have to find the first positive integer that is not present in nums. And this would have been easily implemented using hash set our data structure, but we are set that we must implement this in big O of n time and big O of one space. So which basically means that we cannot use any extra data structure. We have to store anything we have in the existing array itself. So what's my best case? Like, let's say I'm given an array. What can be my first missing integer, positive integer? It can be one, correct? What is my worst case? Worst case, in my array, I have all the numbers from 1 to n, like 1, 2, 3, 4, 5. Then my first missing integer will be positive integer will be n plus 1, correct? So my answer lies between 1 and n plus 1 inclusive. So this is my answer range. Okay. So now that we know the answer range, so I mean we are just worried about a first positive integer that is not there, right? So one thing, let's say if our, you know, if let's say our array was perfect, like let's say it was sorted 1, 2, 3, 4, 5. I'm giving a case. What's my first positive integer here? Since all the elements are at the correct place, the first positive integer is n plus 1, which is 6. Correct? Now, what happens when my array is sorted, but there is some other missing element? So let's say if I had 1, 2, 4, 5, 6. So now we see 1 is at the correct place, 2 is at the correct place, but 3 should have been here, but 4 is here. There's a mismatch. So we immediately know 3 is the answer. And my question is that can we somehow get this array without using arrays or sort? Yes, we can. How? We're going to process the number one by one. And if it is not at the correct place, we're going to put it at the correct place. And then in the next iteration, we'll simply check. So let's do that. So let's iterate through the array up until nums.length for I plus plus. Now what we do is we check if my first thing is we are only worried if the number is between 1 and n, correct? So if my nums of I is greater than equal to 1 and nums of I is less than equal to n, what's n? So let's initialize n. Int n is equal to nums.length. So if this is the case, then only we need to process, else we need to continue. So now I'll check if it is correctly placed. How we will check? Now my nums of I should have been at which index? Nums of I should have, let's say if there is something at nums of I, ideally at ith element, which number should be present? I plus 1, correct? So if my nums at I is not equal to I plus 1, then we need to swap. So let's swap the numbers. So let's go have a temporary variable which will store nums of I. Now my nums of I should be I plus 1. Sorry, my it is I is less than between n. So my nums of I mean whatever number is there, it has to go to the correct index. So let's say that my array was one, let's say I'm taking a random array, 1, 2, 3, 4. So now I am at 4. Now my 4 should have been I plus 1, 1. But now 4 is not 1. So 4 has to go to its correct place. What's the correct place for 4? Nums of I minus 1 is the index that it should go here. So int correct index is equal to nums of I minus 1. Right? And then we need to store nums. And now my nums of I has to hold whatever is there at the correct index. So my nums of correct index. Correct. And my nums of correct index has to store 10. Right? So this is the entire formula here that we're using. And since we've correctly swapped, now we come out of the array. Now we run another for loop. I plus plus. Now what we do is we check if nums of I, if let's say I am at I, my number should be I plus 1. If it is not I plus 1, it means that we have found a number, right? So let's say if my nums of I is not equal to I plus 1, then we return our I plus 1 is the missing number, return I plus 1, fine? Else we come out of the loop and we haven't returned anything, then we simply return n plus 1. Why n plus 1? Because everything was sorted and the next positive number that is missing is n plus 1. Now let's do a check here, which is index out of bounds boundary checking, so that we don't get index out of bound exception. So now we are checking that nums of I is in between 1 and n. Fine. So let's say my nums of I is n. So now my nums of I is n. So correct index is n minus 1. Is my correct index valid index? Yes. So let's say if my nums of I is 1. So 1 minus 1, 0. So is 0 a valid index? Yes. So this will not throw index out of bounds exception. So running this, let's see if the test cases pass. Yeah. So there's no I plus plus here. We're just doing the check. So this will be correct index. Yeah. So we see that, just a second. Yeah. Let me fix the format. So the thing here is that one of the test cases failed. Why? Because we are doing we are missing something here. What are we missing? Let's say if I swap this, there can be a chance that a correct number will be shifted to a wrong position. So that's why we need to swap until we have a number shifted to the correct position. That's why we need a while loop here. And we need to also do one check, which is numbers of I is not equal to nums of I, sorry, nums of I minus 1. Nums of I minus 1 is the correct index where our current number should be, and we are seeing if this is the target spot. And this is the current spot. If these two numbers are not matching, then we need to swap. So this is the logic that we have implied here. And yeah, let's run this code right now. So now let's submit this. So my time and space complexity is, time complexity is big O of n. Since we are doing this in, this is big O of n, this is again big O of n. And then we have big O of 1 auxiliary space, since we don't use any extra data structure. So yeah, that was it from my end. Thanks for watching. Bye.